In this video, let us discuss two concepts. One is about the equivalences, another one is about the implications or tautological implications. So let's see the first one. See the question. Show the following equivalences. So you can see the question there. This is, you see, P conditional, Q conditional P. This is on the left hand side of the equation. And in the right hand side, you see this is not P conditional, P conditional Q. So what you have to prove is, in case of equivalence, what is there on the left hand side of that symbol? See this symbol. This is equivalence symbol. Okay. So what is there on the left hand side and what is there on the right hand side should be same. This is what we have to prove. So you start with the P and Q. You know that method for true, 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 false, false, true, false, false. So once you do that, you find out this one, that is Q conditional P. Now what is meant by this conditional P? So when will we say this conditional? When the first one is true. So here first one means this Q, because here you see Q conditional P. So this is the first one and this is the second one. Okay. So when the first one is true and the second one is false, see here, first one is true, second one is false, then we get the result as false. In all the other cases, it will be true. Okay. So that is this Q conditional P. Next you see this one. So P conditional, Q conditional P. Now for us, this is the first one, this one. This is the first one, and Q conditional P is the second one. Here you see, do we have any such things where first one is true and second one is false? So we don't have any such conditions. Therefore, what is remaining here is, what we get here is all trues. Okay. So now you move on to the right hand side of the equation. See here, this is not P. See, already we have a P. So not P means exactly opposite. If P is true, not P is false. Okay. So same way we get this F, T, T. Next is this one, P conditional Q. So P conditional Q. Now this is the first one and this is the second one. So what is the condition for false? You remember the condition for false. First one should be true, second one should be false. See, first one is true, second one is false. Then we get here this as false. In all the other cases, you see, it is true. See here it is true, 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 and true. Now last one you see, not P conditional Q. See, not P is here. This is the not P. So for us, this is the first now, and P conditional Q is here. This is the second. So what is the condition for false? First one is true. First one should be true. Second one should be false. We don't have any such cases. So finally what we get is all trues. See, left hand side also we got it as true. Right hand side also we got all terms as true. Therefore we can conclude that equivalence. Okay. Then once you do that, you need to conclude hence. See, this statement is very important. Hence the given statement. See, this is, you have to write this. Okay. This is about the equivalences. So equivalence, what you have to do? Left hand side of the equation and right hand side of the equation should remain same. Then we call it as equivalence. Next one is about the tautological implications. See the question here. Show the following implications. So implication is, you see the symbol also there. See, this is the symbol for implication. Previous one, the symbol was different. Both side arrows it was double line. So here what you have to do, when do we say it is, the implication term we are using? This is if you consider this term as A. Okay, I'll use another color. See, let's take this term. Let's say this is A and this is B. So what is the condition? When do we say that the given equation is following implications? So a statement A is said to be tautologically imply a statement B if A conditional B is a tautology. Okay, that we need to check. Okay, now what is there on the left hand side of the equation? You take it as A. What is there on the right hand side of the equation? You take it as B. Let's start from the same method. See, you know what is P and what is Q terms. Again the same thing, true true, true false, false true, and false false. Okay, so here you see P and Q. So P and Q means when both are true, you get this as true. Understood? If any one is false, you will get it as false. That is on the left hand side. Here you see in the right hand side, we have this P conditional Q. So P conditional Q, what is the condition? First one is true, second one is false, then you get it as F. See, first one is true, second one is false, then you get it as F, false. All others are true. Okay, now what you have to do? This is A and this is B. Okay, now you check A conditional B. So A conditional B means, you see if any conditional measures are taken here. First one is true, second one is false. Do we have any such things? First one is true, second one is false. Nowhere it is matching. So if first one is true, second one is false, then it is false. So here we don't have any such conditions. So this entire thing is true. That means it is a tautology. Okay, so if A conditional B is a tautology, then we can conclude that A implies B. So here don't put the double arrow here on the last column. No, that has to be written as a conclusion. Otherwise it is not proper. I hope you understood the difference between equivalence and implications. Many such problems are worked out in the notes. You may refer that. This is only for your understanding purpose. Okay, thank you.